Hello, welcome to Wacky Math Facts. We're here to teach you some math facts, hint the Wacky Math Facts. I'm Dr. Triangle, and I'm here to teach you about the vocab for 5-3. Centroid of the triangle. The point of concurrency of the medians of a triangle is the centroid of the triangle. That point there, centroid of this triangle. Orthocenter of the triangle. The point of concurrency of the three altitudes of a triangle. There, where all those lines meeting, is the orthocenter. The median of a triangle. A median of a triangle is a segment whose endpoints are a vertex of the triangle and the midpoint of the opposite side. That line there is the median. Altitude of a triangle. An altitude of a triangle is a perpendicular segment from a vertex to the line containing the opposite side. This triangle here has three, which all triangles have three altitudes of. This here is an altitude because it forms a 90-degree angle. This is one of them because it forms the orthocenter. And this here forms a 90-degree angle, so it is also one of the altitudes. And that is all the vocab for 5-3. Yeah. Pause.
Now, Sam. Somebody has to hold this. What's your name again, Sam?
Am I holding this up? Want me to hold your notebook?
No, I'm zooming on this.
You just said the S word on live
I'm sorry. This is the centroid theorem. The centroid of a triangle is located 2/3 the distance from each vertex. So, to the midpoint of the opposite side. AP, which is this line segment, equals 2/3 of AY. So this part of the line segment is 2/3 of the whole entire AY. And BP is 2/3 of BZ. And then CP, stop shaking it, is 2/3 of CX. So as you can see, these sides would be congruent due to the centroid theorem. These sides would be congruent, and then those two sides would be congruent. That's the centroid theorem.
You're next.
Yours hurt. What are you laughing at?
You want me to hold this? Or do this one?
Yeah, okay. Hi, I'm Dr. Bond. Okay, this is using the centroid to find segment lengths. Okay, in triangle ABC, which is this, ABC, if AF, where is it? AF equals 9 and GE equals 2.4, you have to find each length. Okay, now we're going to find AG using the centroid theorem. We're going to do AG equals 2/3 AF, which means AG equals 2/3 times 9 because AF equals 9. And then that's going to get AG equals 6. And then now we have to find CG using the centroid theorem. So we're going to do CG equals 2/3 times CE, which is that line. And then we're going to do CG plus GE equaling CE. Yeah. And then GE equals 1/3 CE. I don't know what that means. GE, yeah. Then 2.4, I guess, because GE is 2.4, equals 1/3 CE.
This ain't working.
And so in the end, 7.2 equals CE. So that line segment is 7.2.
Dr. Schnagenberger here. If you haven't tuned out already, I want to take you on a little test drive on example 2. Read with me as I read along. First, we're going to understand the problem.
The answer will be the coordinates of the centroid of triangle PQR. The important information is the location of the vertice. P is located at 3, 0. Q is located at 0, 8. And R, you gotta love those R's, located at 6, 4. The second step to solve this would be to make a plan. The centroid of the triangle is the point of intersection of the 3 medians. So write equations for 2 medians and find their point of intersection. This is what the equations would look like, and this would be how you solve it. Never mind the glue, we had a little malfunction here at Wacky Math Facts. Let M be the midpoint of QR.
We're at 6 minutes.
Is that good or bad?
Bad.
Okay.
Hurry.
Let M be the let M be the midpoint of QR and N be the midpoint of QP. M would be the midpoint of these 2 points, and N would be the point of these 2 points. And once again, that is it solved. Let's take a look back for step 4. Let L be the midpoint of PR. The equation for QL is y minus 4 over 3x plus 8, which intersects x equals 3 at s, which is 3, 4.
Show us on the graph.
You know. Oh, dude. Okay. 3, and then we go up 1, 2, 3, all the way up to 4.
Go! Your turn.
Okay, we're here to teach you the vocab for 5-4. We are going to teach you some wacky math facts again, and I'm Dr. Triangle back again. Well, the mid-segment of a triangle. The mid-segment of a triangle is a segment that joins the midpoint of 2 sides of the triangle. That right here, that triangle right there with 3 points, that is the mid-segment of the triangle. And this is the vocab for 5-4. Thank you.
Okay. This is the triangle mid-segment theorem. A mid-segment of a triangle is parallel to a side of the triangle and its length is half the length of that side. So as you see here, due to this theorem, DE would be parallel to AC. And then DE equals 1/2 of AC. So these 2 sides would be congruent, and as with those 2 sides, be congruent. That is theorem, the triangle mid-segment theorem.
Now what?
Who's example?
Example 1, we don't have a graph for it.
No, because he's supposed to go, but I never finished the graph.
Oh my good God. They don't need it. Just read your example.
Okay.
Hurry, we have 1 minute.
Go to the book, go to the book.
30 seconds.
No problem for me.
Still forget what you're talking about.
Examining where are you? That's example 2.
Oh God. Go.
Examining mid-segments in the coordinate plane. In triangle GHJ, I can't see with the camera right there. Show that the mid-segment KL is parallel to GJ, and that KL is equal to 1/2 GJ. Step 1, find the coordinates for K and L. You'd use the midpoint theorem, or midpoint formula for line GH, right there. And then you'd get -6, 2 for your coordinates.
You're over 5 seconds.
Is that good?
No.
Okay.
There's 40 seconds, 20 seconds left.
Next we would use the midpoint formula to find the midpoint of HJ, which right there. And then you would get the ordered pair of -2, 4.
5 seconds.
Step 2, compare the slopes of KL. Okay, now what do we do?